Unit 1, Number. The objective of this tutorial is to define direct proportion and inverse proportion. The description of the objectives is on page 1. We will begin with direct proportion. An example of direct proportion is when one quantity is multiplied by 2, the other quantity is also multiplied by 2. For example, if 2 kilograms of apples cost $3, then 4 kilograms of the same type of apple costs $6. Which means that if I have 2 kilograms of apples, their price is $3. Thus, if I increase the quantity by multiplying it by 2, then I will have 4 kilograms of apples. Therefore, the price will increase, and instead of paying $3, I will pay $4. We must observe that there are two factors moving together, which are the weight in kilograms and the price in dollars. If the weight increases, then the price will increase, and if the weight decreases, then the price will decrease as well. This type of relations is called direct proportion. The meaning of direct proportion is that the two variables, which are the weight and the price of the cost, are changed in the same way. Thus, if the weight increases, then the price will increase. However, if the weight decreases, then the price will decrease as well. This means that when I bought 2 kilograms of apples, their cost was $3. And when I bought 4 kilograms, I multiplied it by 2. Thus, I must also multiply the price by 2, and the price will be $6. On the other side, if I bought 1 kilogram of apples, I will have to divide it by 2. Thus, I will also divide the price by 2, and the price will be $1.5. Direct proportion takes place when two variables change simultaneously in the same way. This means that when one variable increases, the other will also increase in the same manner. Just like this example, when the weight was multiplied by 2, the price was also multiplied by 2. So this is what is meant by direct proportion. If we look at this table, we will see the two variables, which are the weight and the cost. The cost of 2 kilograms is $3, while the cost of 4 kilograms is $6. Let's sketch them on a graph. The cost will be on the horizontal line, while the weight will be on the vertical line. For the cost, this will be 3 and 6, while for the weight, this will be 2 and this 4. When the cost was $3, the weight was 2 kilograms. When the cost was $6, the weight was 4 kilograms. When we connect the dots, we get a straight line passing through the origin. Thus, the direct proportion is represented on a graph by a straight line passing through the origin. To continue explaining the graph, in the case of direct proportion, let the cost be x and the weight be y. So the mathematical representation between the variables x and y will always be written as y equals k times x. Where x is a constant and the constant is multiplied by x. To get the value of k, we can substitute the values of x and y that correspond to each other. In this case, y is 2 and x is 3. To determine the value of k, we substitute them in the equation y equals k times x. Now we divide both terms by 3, and then k will be 2 divided by 3. The mathematical representation in this case will be y equals 2 divided by 3 times x. That if we substitute the value of x by 6 in the equation y equals 2 divided by 3x, y will be equal to 2 divided by 3 multiplied by 6. The 6 will be divided by 3 and the answer is 2. Then we multiply 2 by 2, y equals 4, which is true. Also, we can complete the table by substituting one of the values, which is x or y, to get the other one. To conclude, if the increase in one quantity leads to an increase in the other quantity, then this is direct proportion. The representation of the direct proportion on the graph is a straight line passing through the origin. The mathematical representation of direct proportion is y equals k times x, which means y is equal to a constant multiplied by x. Now we move to the inverse proportion.